सभागार में संचालित की जा रही है। मैं एक बार फिर अल कबीर पॉलिटेक्निक के उत्तरदायित्व को समझते हुए आप सभी का जो ऑनलाइन और ऑफलाइन भूमिका में है, मैं सभी का तहे दिल से स्वागत करती हूं, हार्दिक अभिनंदन करती हूं। अब मैं आमंत्रित करती हूं हैंड्स ऑन सेशन के लिए डॉक्टर चंद्रशेखर आजाद सर को।
Good afternoon, one and all present here. Okay, now this is the time for hands-on session. Okay, so basically, time is very less. So I will introduce one tool. Okay, that is widely known tool, and easily from without any coding experience that you can do it. Even the many researchers publishing papers using that particular. This is the among top 10 tools. Okay, so the name of the tool is Weka. Later on, what I will discuss about the Python. Weka. Okay, I already installed that. Okay, you have to. This is open source tools. You directly go to Google and search that and download, and you can use it. Okay, so I opening the Weka. अच्छा नहीं यार कर दीजिए आ गया ना ठीक है so open Weka then go to Explorer so this screen will open now the very first task is load the data set okay load the data set okay and if you are training supervised learning or if solving the classification problem then your data set must be labeled okay so go to the open file then load the data set here I am loading iris data set iris classification for that what I am loading CSV file so this is the data set okay the data set having 4 attributes sepal length actually iris is the flower okay so 3 types of the flowers are there iris certosa iris versicolor and iris virginica 3 iris flowers are there the 3 plant flower varieties are there okay so and these are the 4 attributes that considered sepal length sepal width petal length and petal width and based on these 4 attributes the flower is classified as iris setosa iris versicolor or iris virginica these are 3 types of flowers are there okay so I loaded the data set and this is the label data set the last 5th number attribute that is specifying the class level okay and so this is the output and the remaining 4 sepal length sepal width and the petal length and petal width these 4 are the input okay so what I did actually what whoever has developed that particular data set what he or she did they okay collected 150 flowers and they measured each and every flower sepal length sepal width petal length and petal width like iris setosa 50 flowers they measured iris sepal length sepal width petal length and petal width okay and 4 attribute then 5th one is this is iris setosa second flower they measured all these things then we written iris setosa similarly for 50 flowers they collected and okay calculated sepal length sepal width petal length and petal width and they written this is iris versicolor okay and so on so this way what total you can see here total 50 samples for iris setosa 50 for iris versicolor and 50 for the remaining flowers okay so total 150 numbers of the sample they collected and this is the one of the benchmark data set for the classification problem this is okay perfect data set for testing any algorithm okay so now what we will going to do let's suppose that what I want to train the decision tree model so go to classify then here choose the name of the classifier okay go to choose and here so many types of classifiers are there so basically decision tree is a tree classifier and the name of the tree is J48 here the decision tree so I selected that now model evaluation technique I discussed like how to test the performance of that particular so you can apply any other test data set or you can divide the data set into cross validation k-fold or you can split the data set into training and testing set. So here, suppose that I am using, I want to apply 70% of the data set for training purposes and the remaining 30% of the data set for testing purposes. So 70-30 training and testing. So after setting that particular, let's click on the start. So this way what model will be generated and the performance will be ready. Okay, so I clicked on the start. So you can see here, this is the model that are generated. This is the actually what trend decision tree. If petal width is less than 0.6, then definitely that flower will be setosa. Otherwise, if petal width is greater than 0.6, then you have to check petal width less than equal to 1.7 and petal width less than equal to 4.9, then that must be a versicolor. Otherwise, what that particular will be classified as Iris virginica, and the remaining that depends on the condition. Okay, so this way what that training and testing under. What I did, I loaded the data set. Okay, if I want to do the pre-processing, then do. Otherwise, what directly select the classifier and then you have to select the appropriate test option, whether you want to do k-fold cross validation or you want to do training testing split or you want to supply any other data set. Okay, and then click on start. So this way what the model is generated and on the supplied test split remaining 30% of the data, it tested the model performance also. So you can see here on like 30% of the data, it means that what 50 samples we supplied for test case. So among the 50 supplied test cases, 45 supplied test cases, 43 correctly it classified and the remaining 2 it is wrongly classified. So the accuracy of that particular is around 95%. 95% accuracy and error is 4.4%. Similarly, what suppose that if you want to do it for any other classifier like Naive-Bayes, that is based on the Bayesian theorem, Naive-Bayes. So select the classifier and then select the appropriate test option like supplied test set. The evaluation will be based on cross validation or based on the percentage split. So 70% I am considering, or you have to vary it for the different training testing split. Okay, so right now what let's fix it up. Okay, 70% and then click on start. So this model will be trained. You can see here in this also we are getting the accuracy of 95.55%. Okay, so for the CS students, that is easy to use. This way what you can, okay, now like in the previous one I trained decision tree algorithm. So you can visualize tree as well also here. Visualize classifier, visualize tree. So this is the tree that is generated during the, okay, petal length less than 0.6, then setosa. Otherwise what, petal width you have to check. If petal width less than 1.7, then again check petal length. If it is less than 4.9, then that particular will be classified as versicolor. Otherwise, if petal length is greater than 4.9, then again you have to check petal width. If it is less than 1.5, then virginica. Otherwise, that particular will be classified as versicolor. So this is the model generated based on the data. So what you have to do? You have to load the data set. If required, you have to do the pre-processing. Then select the classification algorithm. Then you have to select the test option. And then thereafter what, you have to click on the start button. So this way what, you will get the result. How much accurately what it is predicting. You will get the value of the various performance parameters such as like here you can see TP rate, FP rate, precision, recall, F measure, okay, MCC, ROC area, PRC area for the data set. So this is the confusion matrix. Okay, now this is the classification report, not confusion matrix. And in the bottom part, whatsoever it is saying, this is called the confusion matrix. Based on that particular confusion matrix, it is calculating the value of the various parameters such as like recall, F measure, precision, etc. FP road, TP road, etc. So is it clear how to do it? Choose load the data set, then select the algorithm like rule based. Suppose the decision table based, I want to develop. So select the classifier, like I want to do cross validation, like 5-fold cross validation. So you have to enter here 5, then click on start. So this way what the result is generated here. So only okay in the couple of minutes, simply what you have to collect the data set, okay, load the data set, select the appropriate algorithm, okay, then configure the algorithm. Here so many parameters are there, like parameter tuning you can do it here by clicking on the this choose bar. Okay, you will select that, okay, vary the various parameters and then do it. So this way what you can do the classification. Hope is it clear what to do? This is the name of the tool is Veka. For non-engineering, those don't have the coding background, they can simply what download the Veka, load the data set. Okay, might be what there are the some of you are working on the image. Okay, there are the separate modules there. This is only working on the CSV file. There are the other modules are also in that, but you have to load the images and accordingly you have to process. So that it will take time. That's why what I come up with like a simple step that anyone can okay start their like a small project etc. with the help of this small tool. This is the well-known tool available here. Veka WEKA, download it, install it. Okay, for that Java is required. Okay, after that what you have to load the data set. That if you are solving the classification problem, then your data set must be labeled. If you are solving the unsupervised learning algorithm, then your data set must be unlabeled. Okay, suppose that I want to do clustering task unsupervised. So go to the cluster. Here you have to select the clustering algorithm name. Suppose one of the famous clustering is simple k-means. Okay, okay. Here you have to supply the number of clusters. Here minimum cluster, suppose that 3. I know there are 50-50 samples are there for 3 variants of the iris flower. Okay, so 50 flowers. So I want to group those samples into 3 groups, 3 clusters. Okay, so I selected that, then click on OK, and then click start. So you can see here it is okay. So yeah, this is the cluster instances. So perfectly what it is classified that 0 means iris setosa, 1 means iris versicolor, and 2 means iris virginica. So 50-50. So 100% accurately what it is classified the samples in the 3 clusters. Okay, you can do it on 2 clusters as well. Okay, by simply varying the number of clusters enter to 2. And then select that. So you can see here 2 classes. In one class 100 samples and another class. So here the value of the k is very sensitive. The output will depend on the what number of clusters you are selecting. So this way what easily, if I want to classify, simply go to classify and appropriately you have to select the like multi-layer perceptron, neural network that I shown. You have to select the parameter, algorithm, okay. You have to use the cross validation 5-fold, 10-fold, 15-fold, then click on start. Now MLP is ready. It is having the accuracy of 96% and error of 4%. In the previous one, okay, the accuracy is around 95.55. So MLP is giving better performance as compared to the decision tree or other nav-wise algorithm here. So easily you can do it. Okay, so hopefully that is clear for the GUI. Okay, let me tell you that how to minimal coding experience, how we can do it with the help of Python. Okay, so okay, don't fear about this thing. Only I will tell you that only 2 lines you have to change. Okay, the model will be different. Okay, so like these are the requisite okay library module that is required, like pandas for loading dataset, NumPy for numerical calculation, matplotlib for drawing plots, okay, graphs etc., and Seaborn that is also for graph etc. Okay, you have to load the dataset. Here dataset is iris, the same dataset I consider. Okay, so this way what with the help of pd.readcsv to load the dataset. That dataset in the comma separated value format, CSV file. Okay, that's why file name.csv. Okay, so this way what dataset loaded into iris_df. So this way I shown the dataset. So dataset is shown. Now I want to determine that how many rows and columns are there in that particular. For that what iris_df.shape. So here it is showing that 150 numbers of rows are there and 50 numbers of columns are there in that particular loaded data file. Okay, so now after that what, let's visualize, okay, like pair plot that we will going to do. So for that what Seaborn module that we will going to use. So SNS dot pair plot, okay, like the attribute by attribute distribution will be shown here, like this way, attribute by attribute. Okay, now next task is what we have to keep input in one, okay, data frame and output in another data frame. So here you can X what we are putting all the attribute except class. So we are dropping here the class attribute, that is variety. So sepal length, sepal width, petal length, petal width will be in the X. Or in Y we are putting the variety, iris DF variety. So X representing the input and Y representing the output. Is it clear? डेटा सेट में इनपुट और आउटपुट अलग हो गया. अब हम लोग क्या करेंगे, इनपुट को उसको स्प्लिट करेंगे डेटा सेट को ट्रेनिंग एंड टेस्ट में. सो फॉर दैट व्हाट ट्रेन टेस्ट स्प्लिट, एक्स इज द नंबर ऑफ एट्रीब्यूट, वाई इज द क्लास और टेस्ट साइज दैट इक्वल 0.3. मतलब टेस्टिंग डेटा सेट में 30% डेटा रहेगा, रिमेनिंग 70% किस में रहेगा, ट्रेनिंग में रहेगा, जो वहाँ पे ऑप्शन क्लिक करके किए थे. सेम एक्टिविटी वी आर परफॉर्मिंग थ्रू द कोडिंग. Like previously what in couple of minutes ago we have seen that particular with the help of the Beka tool, okay, and random state too. Okay, now so training testing split हो गया. So it means that what we model evaluation technique whatsoever we applied here, that is train test split. ठीक है, तो हमने क्या किया, डेटा सेट को लोड किया, देन x और y को अलग किया. x में क्या है आपका ऑल एट्रीब्यूट्स, y में क्या है आपका क्लास लेवल. हो गया. अब हमने क्या किया, उस डेटा सेट को ट्रेनिंग और टेस्ट में स्प्लिट किया. एक सिंपल सा एक लाइन है, ट्रेन टेस्ट स्प्लिट. ओके, देन द रेशियो ऑफ द ट्रेनिंग टेस्टिंग इज okay will be 70-30. So you have to specify the here data training data set size, that is 0.3 means 30% of the data set will be considered in the testing data set. हो गया, ज़्यादा याद करने की जरूरत नहीं है. ठीक है, हो गया. Then this is the classifier. So you have to import that particular from sklearn library. I will show you that. Okay, so that available in from sklearn import tree dot decision tree classifier, so that I initialize into neigh. ठीक है, मॉडल यहाँ पे इनिशियलाइज हो गया. अब हम लोग क्या करेंगे, अब बस उसी को neig dot feed x train. This is a training data set and the corresponding the class levels are in y train, x train, y train. Is it clear? So we supplied the training data set here and associated class level, and this is training the model. Now after that what model is trained, now we are finding the accuracy of that particular. So for that what you need to apply neigh dot score. Here this is x test, this is the priorly known class of testing data set, and y test, this is the output generated by model. x test में क्या है, जो पहले से हमको उसका आउटपुट पता है, और y test में क्या आया, जो मॉडल निकाल के दे रहा है हमें. ठीक है, ये हो गया. तो x दोनों को कंपेयर करेंगे, उसके बेसिस पे हमारा क्या होगा, एक्यूरेसी कैलकुलेट होगा. ठीक है, तो देखिए ये 95.55% ऑफ एक्यूरेसी. सेम रिजल्ट वी गोट इन द वेका. 0.95 we will going to convert into the percentage, then that will be 95.55%. ठीक है. Now suppose that so these are the prediction for the each and every samples available in the data set, like around 45 of the samples are there in the testing data set. This way what we can generate the confusion matrix. Okay, confusion matrix basically what that tells that what this is the okay a 3x3 graph plot between the predicted and actual. So it means that what you can see here, how many like 0 1 2 0 for iris setosa, 1 for iris versicolor and 2 for iris virginica. How many 0 are predicted as 0, how many 0 are predicted as 1, and how many 0 are predicted as 2. How many 1s are predicted as 0, how many 1s are predicted as 1, how many 1s are predicted. So in each and every cell that number is showing. So in the very first cell here you can see here 2 is predicted as 0. So 0 numbers of sample which are actually 2 in class 2 and are predicted as 0. Similarly, like in the middle, 14 is there. It means that what? Actually that is 1. 14 numbers of samples are actually 1, but that is predicted as 1. Okay. Similarly, your like last one, 12. Actually that is 2, class 2, and that is predicted as 2. Okay. Similarly, what in the remaining cell you can see. So accurately it is predicting that only what there is a divination in the 2 samples. Like actually that is 1, but that is predicted as a 2. In the last, middle last. Actually that is 1, but that is predicted as class 2. So this way what we can compute the accuracy of that particular. A new prediction करना है तो simply आप you have to specify the 4 parameters: sepal length, sepal width, petal length and petal width to the model, and that is predicting that that particular is a Iris virginica. This flower is predicted as Iris virginica. Okay, so this way what we can do. So now question arises that suppose that I want to build another model, then what to do? Simply in one place you have to do the modification. Let me show that sklearn. This is the actually module that sklearn. Go to classification. Okay, right now what we use decision tree. Decision tree is there. Okay, decision tree we did that. Okay, we included like from sklearn import tree. Yet this line and this line I used. Then there are this fit is same line. So suppose that what I want to do it with the help of another algorithm. Let's change the algorithm to support vector machine. Hey, okay, go to the classification. Change these 2 lines. क्या क्या करना है? From sklearn import SVM and CLF equal to SVM.SPC. 2 line change करेंगे. Earlier was what? Decision tree based iris classification system. Now if you are going to change these 2 lines, then that become SVM based iris classification. So, okay. So I am not updating the file. I will show you that how I did here. दो लाइन चेंज खेल चेंज हो जाएगा. ये है जैसे SVM बेस. ओहो, दिस इज नॉट. Rest of the things will be same. Only 2 line will going to change. The rest, okay. You can see here. Okay, so like you can observe that let's load the data set. Okay, here go to this. Here this is the name of the Google Colab online I am doing. Load the data set. Here somehow data set is there. Every time you have to load the data set. I am loading the iris data set. Okay, the data set is loaded. Let's close that. Okay, देखिए module load किए थे सही है. We loaded the data set. We have seen the attribute about that. Okay, we seen the dimension of the data set, rows and column. Then we visualized with the help of pair plot, attribute by attribute visualization of the data set. Then thereafter we separated the inputs and outputs. So in X what we incorporated only input field, sepal length, sepal width, petal length and petal width. Then thereafter in Y we introduced the class level. Okay, variety of the plant. Then here training test split, same code. Then thereafter here only modification I have done here. From sklearn.svm import SVC. You can see here in earlier one decision tree what we retain. This one. Okay, from not this one. Okay, from sklearn import tree, what we retain here in SVM, from sklearn.svm import SV. You can see here in the original file. From sklearn import SVM. Okay, next line what we have to change? SVM.SVC. So here what we did here, SVC equal to SVC. Little bit changes is I done. Okay, so only two line I change and the remaining things are same. Okay, so here and then I did prediction. So in previous one what we got 95% of accuracy, and here what we are getting 97.77% of accuracy. So two line changes and remaining things are same. Okay, but like in the decision tree, in decision tree we have to generate the decision tree. So obviously for that what the different line of statement will be required. So the rest of the things will be same, only what like visualization and all, for that the statement will get changed. Is it clear? Okay, so only the rest of the things are same here. The same statement. Okay, let's check another one, like suppose a radial basis function. Okay, you want to do, no issue. Okay, statements are same thing. Training split is same. Here from sklearn dot Gaussian process, import Gaussian process. Okay, here, okay, let's see that particular with sklearn. Here changes is I did from this place only. Here these two lines, three lines, and the rest of the things are same. So if you understand that, where I will do necessary changes, my model. So this one will be a radial basis function based iris classification system. So let me show you that where you will browse and where you will find out what necessary statement I will incorporate in my file, such that what my model will be different. So go to the sklearn, penalty of classifiers are there. So many classifiers are there. Okay, this is sklearn, go to classifier. Here so many types of algorithms are there. Simply what 2-3 lines you have to change, the remaining model will be changed. So like I did support vectors. Okay, nearest neighbor, KNN classifier. So बताइए यहाँ पे देखिए क्या लाइन चेंज करना पड़ेगा. So first line आपको चेंज करना पड़ेगा from sklearn dot neighbors import nearest center, okay, nearest centroid, and then fit वाला तो सेम है. एक ये वाली लाइन चेंज करना पड़ेगा आपको उसमें, और एक ये वाली लाइन, और नीचे सब सेम है. So 3 lines you have to do it. Okay, so here like hundreds of classifiers are given. Okay, so important task is here the collection of the data set. Okay, you have to collect a unique data set for which the systems are not yet developed. Okay, and you can do prediction task easily with the help of Python. Is it clear? Okay, let me show another one. Till now what I haven't executed that. Let me show with the help of execution how it is takes place. So what you have to do, go to Google Colab, Google online, how you can do it. Go to Google. Okay, here you have to search Google Colab. Okay, welcome to the Colab. Okay, here new notebook. Okay, it is taking time for environmental setup. Now after that, okay, so this is cell. Okay, here you have to enter the command, and then if you're going to click here, then that will going to execute. That's what I did here. Okay, suppose that here data set is not there, so go to upload option, select the data set, and the data set will be uploaded. So already I written the code, I am not typing here right now. So I loaded the data set. Necessary modules are required to execute that. So if you click on that particular, that will execute. So right now that the tick marks came, it means that is executed without any error. Now load the data set. So data set is loaded. Now I want to see what is the data set, what about the data set. I want to know the information about the data set, how many attributes are there, how many records are there. So click on iris df. So here after that what I came to know that what sepal.length, sepal.width, petal, these are the attribute, and this is the class level. Okay, at the end what I I want to know that what how many rows and columns are there. Iris df dot shape. So 150 numbers of rows are there, 5 numbers of columns are there. Actually, okay, already is showing the output. So it is better if you will go through uploading notebook. Okay, so upload notebook, browse, like decision tree. I uploaded the notebook. Okay, from beginning let's do it. Okay, actually I opened through Google Drive. So this way files is uploaded. Now no output is showing here. Let's upload the data set again. Okay, so run the modules, load the data set. Okay, okay, I am getting the output about the files. Let's see the rows and columns available. Now let's draw the pair plot. Okay, so you separated the y class level. Okay, training testing is split. Okay, let's suppose that I am giving here earlier what we got around 97% accuracy. Suppose that I am giving 0.5. It means what? Here I am considering 50% of the data set for training and the 50% of the data set for testing purposes. So 0.5, that's why I, okay. So let's split the data set now. X train, that is the training data set, its corresponding, okay. There is some error came, okay, where X is not defined. Okay, earlier what? Okay, some, okay, previous cell I not executed, that's why. Okay, X, Y. X ट्रेन में क्या आएगा आपका बताइए X ट्रेन में क्या आएगा ट्रेनिंग सेट का ऑल एट्रीब्यूट्स और X टेस्ट में उसका क्लास लेवल ठीक है सॉरी X ट्रेन में ऑल एट्रीब्यूट Y ट्रेन में उसका कॉरेस्पॉन्डिंग क्लास लेवल X टेस्ट में टेस्टिंग का ऑल एट्रीब्यूट और Y में उसका कॉरेस्पॉन्डिंग क्लास लेवल ठीक है आ गया अब इसको मॉडल को ट्रेन करते हैं मॉडल को इनिशियलाइज करते हैं देन हियर वी आर ट्रेनिंग द मॉडल ऑन X train and Y train. X train all the attributes and Y train contains the corresponding class levels. ठीक है सपोज यहाँ पे आपको देखना है कि हमको नहीं पता चल रहा है कि X train and Y train क्या है तो इसके पहले आप जाइए यहाँ पे एक प्लस ऑप्शन आता है इसे कोड जैसे Y train देखेंगे रन करा दीजिए Y ट्रेन देखिए है ना एक आउटपुट है और अगर यहाँ पे X ट्रेन कर देंगे तो ऑल 4 एट्रीब्यूट दिखाएंगे सेपल लेंथ सेपल विड्थ पेटल लेंथ एंड पेटल विड्थ देखिए आया ना तो उसमें इनपुट है और Y वाले में आउटपुट है और उसका मॉडल ट्रेन करते हैं उसके ऊपर सो बेसिकली व्हाट व्हेनेवर फिटिंग द मॉडल आई ऑलरेडी डिस्कस्ड अबाउट what is taking place in the background model train with the help of entropy okay Gini index okay or gain ratio are used for the purposes of that based on that what decision tree is constructed model fitting is done okay so model is fit now let's whatever the model we trained okay what is the performance of that particular let's apply the test data set मतलब हमें पता है कि 2 + 3 5 होता है सामने वालों को पूछना है कि आउटपुट मुझे 5 पता है और उससे पूछ के देखेंगे 2 + 3 कितना होता है अगर वो 5 बताएगा मेरा पहले से जो आउटपुट है उसे मैच करेगा इसका मतलब एक्यूरेट थी तो यहाँ पे भी हम क्या कर रहे हैं हमारे पास कुछ सैंपल है उसके बेसिस पे हम लोग क्या करेंगे डिटरमाइन करेंगे कितना एक्यूरेट है ये ठीक है तो एक्स टेस्ट में हम लोग अप्लाई कर रहे हैं so it is getting 94 point okay earlier what we taken 0.3 tested now we taken what 0.5 so you can see here that accuracy is reduced to 94.6 6 6. Okay, so now after that what what actually predicted that you want to see, then NEIGH model dot predict on the test data set. So these are the prediction that is predicted by the model. Okay, now if you want to see the confusion matrix, then you can apply that. So you can see here confusion matrix is showing here. Okay, then heat map of the confusion matrix. Okay, so 27 samples are belongs to 0 class, and that is predicted as 0. Okay, 1 22. So this way, by this one, okay, by diagonal also we can calculate the accuracy. Okay, new product, suppose that a new flowers I got and I want to determine whether that is Iris setosa, versicolor or virginica. So simply what, in the model, this is the model NEIGH dot predict, I given the new sample, the measurement of the flower, sepal length, sepal width and petal width, I given input to that particular trend model. So what output we are getting, you can see here, that is Iris virginica, that is predicted. Now we want to suppose visualize the decision tree, then tree dot plot, and here the model I am giving. So this is the actually tree. Okay, so because size of the tree is big, that's why what that is showing in that format. If you want to visualize that with the help of that particular command like tree dot plot tree NEIGH, then this way that will be generated. So if you observe that decision tree, analyze that particular, okay, so that is predicting that based on the values it is giving that. So it is uses the Gini index. Okay, based on the Gini index, that it is modeling that particular tree. Other attribute selection parameters that you can use like gain ratio and that information gain. Okay, so basically the different types of decision tree are there. Okay, information gain that is used in ID3. The 3 decision tree models are there. So many are there, but 3 popular decision tree algorithms are there. One is ID3, that is using attribute selection measure as a information gain. Another tree is that is called decision tree C4.5, that is using attribute selection measure as a gain ratio. And another tree is CART, classification and regression tree, that is using attribute selection measure Gini index. तो एक फॉर्मूला चेंज कर देंगे, आपका ट्री चेंज हो गया. The entire process is same. Only thing is that what here attribute selection is okay. Likewise, what attribute selection means what? I have 4 attributes: sepal length, sepal width, petal length, petal width, and I want to make a tree from that particular. Then obviously what? Which attribute will going to place into the root node? First node किसको बनाएंगे? So first of all, what we will going to compute the Gini impurity of attribute 1, attribute 2, attribute 3 and attribute 4. The attribute which have the least Gini value, that will be treated as a root attribute. Okay. So based on that, what on the remaining attribute will now divided into left subtree and right subtree. Okay. Again, same thing will going to apply recursively into the left subtree and same thing into the right subtree. Okay, that will recursively come unless or until what we will get the all the leaf nodes belonging to the same class. Okay, so this way that will be okay. The rest of the code only the 2 line changes are there, 2-3 line changes are there, and the rest of the things will be same. Suppose that this is about the iris. Suppose that someone want to develop okay heart disease prediction system यूजिंग डिसीजन ट्री, तो इसमें से क्या चेंजेस करेंगे बताइए कि ये हार्ट डिजीज डिटेक्शन सिस्टम बन जाएगा फ्रॉम एनीवन फ्रॉम बीसीए. इसमें क्या चेंजेस करेंगे तो ये हार्ट डिजीज प्रिडिक्शन सिस्टम बन जाएगा, बताइए. हाँ हाँ, डेटा को चेंज कर देंगे तो आइरिस डाटा जहाँ लोड किए तो वहाँ क्या करेंगे, हार्ट डिजीज का डेटा सेट लोड कर देंगे. अगर हमको डायबिटिक प्रिडिक्शन सिस्टम बनाना है तो क्या करेंगे, डायबिटिक वाला डेटा सेट चेंज कर देंगे, नीचे सेम रहेगा. इतना सारा है. ठीक है, अभी इस बीच में अभी किसी को कुछ पूछना है तो पूछ सकते हैं. क्या समझ में आया, नहीं आया? अब इंटरेक्टिव करते हैं. हाँ हाँ हाँ, यहाँ वे का ओपन करके दिखाता हूँ। देखिए, अगर आपका डेटा कलेक्शन आपका खुद का है, ओन है, तो आप इजीली इस टूल को यूज कर सकते हैं। अगर एग्जिस्टिंग डेटा वगैरह नहीं यूज करें, डेटा सेट कलेक्शन इज इटसेल्फ ए टास्क, इटसेल्फ ए वर्क, पीएचडी वर्क, पार्ट ऑफ द वर्क। लेबलिंग तो आपको फिर मैनुअली करना पड़ेगा, या कोई स्क्रैपिंग वगैरह जैसे कर रहे हैं तो उसको कुछ प्रोसेस लगाना पड़ेगा, लेबलिंग करना पड़ेगा ना। देखिए, इसको ओपन करिए आप। जैसे हम लोग कैप्चा यूज करते हैं ना, कैप्चा, दिस इज बस, ओके, सेलेक्ट बस, ट्रक। आप क्या कर रहे हैं आप बताइए तो? यू आर लेबलिंग द डेटा सेट फॉर समवन। हाँ, वो कैप्चा करवा रहा है वो। हाँ, जैसे आप कुछ एक टेक्स्ट की एंट्री करते हैं ना, कैप्चा में आप टेक्स्ट एंट्री करते हैं आप, है ना, क्या इस लाइन में क्या लिखा हुआ है। जैसे कुछ एक आपको कैप्चा दिखाया, कुछ एक सेंटेंस लिखा हुआ है और आपको उसमें नीचे टाइप करना है, कोई एंट्री करना है। एक्चुअली वो डिजिटल आर्काइव को आपको एंट्री करा रहा है। तो ऐसे 10 लोगों से कराया, जिसका जिसका मैच करेगा उस कोडिंग को आपको डिजिटल एंट्री करवाया जा रहा है। तो यहाँ पे देखिए, आप लोड डेटा सेट करिए। ठीक है, यहाँ पे देखिए फिल्टर है, यहाँ पे वो प्री प्रोसेसिंग मेथड्स है। ध्यान से देखिए, यहाँ पे देखिए चूज है ना, चूज में क्लिक करिए, आपको यहाँ पेनल्टी ऑफ मेथड्स मिलेंगे। जैसे सुपरवाइज्ड का है, इंस्टांस बेस्ड है, ठीक है, रीसैम्पल, स्प्रेड, स्ट्रेटिव, क्या लिखा हुआ है, स्ट्रेटिफाइड, रिमूव फॉल्ट्स, एट्रीब्यूट रिलेटेड है, देखिए ना, एड क्लासिफिकेशन, एट्रीब्यूट सिलेक्शन, डिस्क्रिटाइज, okay, merger nominal values, nominal to binary, partition membership. So many methods are there. Actually what, only few of the algorithms are there. You have to upload, upgrade it such that what, you can add more pre-processing method in that particular. तो कहाँ पे जाएंगे आप? जैसे यहाँ पर choose, filter, supervised, attribute, जैसे यहाँ पे discretize, यहाँ पे क्या कर रहे हैं, फर्स्ट लास्ट के बेसिस पर ओके कर दे रहे हैं, अब यहाँ पे अप्लाई कर दीजिए। तो ये सेपल लेंथ डिस्क्रिटाइज हो गया, मतलब एक रेंज में आ गया, दैट विल बी लाइज बिटवीन लाइक सम रेंज लाइक -5 to +5, सब इसमें आ जाएगा।
Sir,
हाँ,
so is this from machine learning or data science? All of this?
मशीन लर्निंग।
Machine learning. And we will learn it in masters
नो नो,
in specialization?
कभी भी कर सकते हैं आप।
No, especially the syllabus.
नो
all
नो
the
नो नो,
included
अभी
syllabus.
राइट, सपोज दैट इफ यू आर even maybe in the diploma there are some subject, maybe data mining etc.
Data mining. We
हाँ,
have that too.
data mining,
in
machine
the
learning,
third
pattern
semester.
recognitions,
We have that too in
okay,
the
in
third
BCA
semester.
also.
BCA, yes.
Yes.
And in specialization, we will learn further.
Don't think about that, what, like if you do specialization then only you can do it. Now
So,
it, हाँ,
so what is the difference between machine learning and deep learning?
डीप लर्निंग क्या है, मशीन लर्निंग में क्या है, डीप लर्निंग आपका
Difference.
हाँ, दैट यूजेज व्हाट, एक्चुअली व्हाट, दैट इज द सबसेट ऑफ मशीन लर्निंग। डीप लर्निंग इज सबसेट ऑफ दैट यूजेज न्यूरल नेटवर्क। ओके, डीप लर्निंग एक्चुअली क्या है, जैसे आपका मशीन लर्निंग में क्या है कि जैसे एक फ्लावर्स है, ठीक है, फ्लावर्स में हमने मेजरमेंट किया, सेपल लेंथ, सेपल विड्थ, पेटल लेंथ एंड पेटल विड्थ, उसके बेसिस में हमने डेटा एंट्री कराया और लिखते गए। डीप लर्निंग एल्गोरिथम में क्या है, अब फीचर एक्सट्रैक्शन की जरूरत ही नहीं है, वो ऑटोमेटिक फीचर एक्सट्रैक्ट करता है। फीचर एक्सट्रैक्ट, इनपुट इमेज दीजिए, वो ऑटोमेटिक फीचर एक्सट्रैक्ट कर लेगा, बताने की जरूरत नहीं है, खाली आप बता दीजिए कि ये क्या है, ऑटोमेटिक वो पता कर लेगा कि इसमें क्या फीचर्स है ये एट्रीब्यूट में। लेवल यहाँ दिया होगा, देखिए, अच्छा लर्निंग रेट, वो सब में लर्निंग रेट नहीं रहता है, सब अलग। जैसे आप KNN क्लासीफायर है, उसमें एक ही पैरामीटर है के, डिसीजन ट्री में कोई ऐसा पैरामीटर ही नहीं है, जो यूजर इनपुट न्यूरल नेटवर्क आप लेते हैं तो वो डिपेंड करता है कि आप कौन सा एल्गोरिदम ले रहे हैं। हाँ, एसवीएम में जैसे आपका पैरामीटर W है, जैसे आप सिंपली WX माइनस बी, तो W एक पैरामीटर है, तो W को आपको फाइन ट्यून करना है वेट्स को, सच दैट व्हाट मार्जिन विल बी मैक्सिमम। जैसे कोई एक जैसे आप कोई सा एल्गोरिथम लेते हैं जहाँ पे वो लर्निंग रेट है तो वहाँ पे वो यूज होगा, सब में नहीं है वो। जैसे नेव बायज में दैट इज सिंपली यूजिंग द वेजियन थ्योरम, कंडीशनल प्रोबेबिलिटी। उस प्रोबेबिलिटी में जैसे हमारे पास ये फ्लावर्स का हमको वेजियन थ्योरम अप्लाई करना है, तो वो क्या करेगा, कंडीशनल प्रोबेबिलिटी, जैसे वी हैव द 3 क्लासेस ऑफ फ्लावर्स, flower 1, flower 2 and flower 3. So whatsoever, like one sample we got and we need to predict it to the flower 1, flower 2 or flower 3. Among these 3 the flower will be, okay. So what we will do here, conditional probability of the unseen data point that it will going to compute for the flower 1, conditional probability for flower 2, conditional probability for flower 3 will be computed, and for which the conditional probability will be maximum, that flower will be labeled to the unseen sample. ठीक है, एक सिंपल सा फॉर्मूला है वेजियन थ्योरम। ओके, so similarly you can do classification, clustering. Here I made one PPT also here about that. So I think that this is about using Python to do the classification using the various classifiers. Okay, here other classifiers are also there. Decision tree, KNN classifier. चलो अब यहाँ पे करके दिखाते हैं इस SVM वाले में KNN कैसे करेंगे। आपको अगर लेमन में है, आपको नहीं पता है, तो ये मुझे ये फाइल आप में को मैंने दे दिया, एंड आई एम सेइंग यू हैव टू, ओके, लाइक दिस इज द फाइल ऑफ सपोर्ट वेक्टर मशीन बेस्ड आइरिस क्लासिफिकेशन सिस्टम, ओके, एंड आई डेमोन्स्ट्रेटेड अबाउट सपोर्ट वेक्टर मशीन बेस्ड आइरिस क्लासिफिकेशन, एंड माई टास्क इज टू, ओके, you have to generate machine learning model iris classification system based on KNN classifier. So what you will do, so suppose that if I will be in your place, then what I will do, I will go to the Google, okay, then search sklearn, okay, go to this, okay, this is the, okay, now classification, okay, I will find out desired classifier, nearest neighbor, so might be this one, okay. Here I will find out the appropriate code and in which I will paste it. So this is, no, this is not this one, nearest neighbor. So I will copy first line, I am copying the very first line. This is the SVM file, you can see here, SVM iris classification. So rest of the things I will keep same. Okay, here only these 2 line I will change. Directly I am copying here. Okay, so ऊपर नीचे कर देते हैं तो थोड़ा सा, हाँ, नहीं हो रहा है। I copied this line. After that what I am pasting that, paste हो गया, still I missed something. Okay, so already that is not needed here. Okay, so from sklearn.sbm, here I am writing what, from sklearn.neighbors import nearest neighbor. वाला line match कर गया. Previous one is for SBC and that is for nearest neighbor. Here, okay, one thing that we can do, and below we are writing SBC dot model, SBC model. So let left side the variable name should be same. So that's why what I am copying that here. Otherwise we need to change below here. Right side will be same. Oh, let me write SBC. This is the variable, okay. Okay, nearest neighbor I am considering two neighbors, algorithm equal to ball tree dot fit. Okay, fit नीचे में लिखा हुआ है, so you can omit that in the same line that is shown here. Here dot fit is there. Okay, so okay, now let's execute all the line one by one. The two line changes and the entire system will be different. Previous one is base SBC base and the next one is base. Okay, here some error came. Oh, previous one. Okay, so this way what that is model is trained, and the rest I already discussed about. Okay, how to test that, how to generate the classification report, etc. Okay, is it clear? If anything that people may ask, otherwise what I will move to, suppose that if you want to develop, yes, these are the different algorithm that it is using here. Inside that you will get idea about. KD tree, okay. So actually what? So many algorithms are there. Okay. Might be you have to explore that. Okay. The definition is about other things here. So many thousands of classifiers are there. So for any person what? You have to know about the working principle of all those things. That is very difficult. Okay. So actually what I am not working on that like KD tree and all. So actually you have to deep dive into that particular, then only okay. So many basic things are there. Actually these are the very fundamental things that we are only focusing on the basic algorithms. Okay. Thousands of parameters are there. So you have not to memorize all the things. Okay. Whenever you are working on a particular domain, you need to find it out the appropriate algorithm and then you have to deep dive into that particular. Okay. Okay. Any question? हाँ बोलिए. Database here, Iris dataset I use. Suppose that if you want, okay, very good question here. Like, suppose that if you want to download the UCI repository, you have to go. This is machine learning repository. Here you will get datasets. Okay, so for the different tasks. So many datasets are there. You can even like micro, gas, turbine, electric energy. For the different engineering branches, you will get the dataset. Here thousands of datasets are there. These are the popular datasets. Okay, you will get. Bank marketing, wine, student performance, online retail. So many datasets are the car evaluation, default credit card client, like so many. Okay, so from here you have to download the dataset and appropriate model you can train and develop the intelligent system. Okay. If any question, then
बहुत बहुत धन्यवाद सर। और इस हैंड्स ऑन सेशन के साथ हम आज 2 दिवसीय राज्य स्तरीय कार्यशाला के पहले दिन के अंतिम पड़ाव पर हैं। मैं आप सबों को बता दूं कि हमारी इस कार्यशाला में फ़िलहाल कबीर वेलफेयर ट्रस्ट के माननीय सदस्य श्रीमान मोहम्मद ज़ियाउल मोबिन अंसारी साहब सचिव, श्रीमान जफ़र इमाम साहब ट्रस्टी सदस्य, श्रीमान मोहम्मद मुमताज़ अहमद साहब सदस्य कबीर वेलफेयर ट्रस्ट यहाँ उपस्थित हैं। इसके साथ ही अल कबीर पॉलिटेक्निक गवर्निंग बॉडी मेंबर श्रीमान शकील गनी साहब यहाँ उपस्थित हैं। तो आप सबसे अनुरोध है कि एक तालियों की गड़गड़ाहट से उनका भी अभिवादन करें। और मैं निवेदन करती से हूँ कि हमारे जो आज के प्रमुख प्रवक्ता हैं उनके साथ एक ग्रुप फोटोग्राफी सर आप सदस्यों का, एक वरिष्ठ सदस्यों के साथ हो जाए तो बेहतर होगा। आप कृपया मंच के समीप आकर के एक ग्रुप फोटोग्राफी ले लें सर। हमारा आज की कार्यशाला जो है संपन्न करने से पहले ये आश्वासन कि हम नवीन तकनीक को अपनाकर नवोन्मेष और नवाचार के माध्यम से इस समाज और दुनिया को आगे की ओर ले जाएं। मैं नोबेल पुरस्कार विजेता भारत के महान दार्शनिक श्री रविंद्रनाथ ठाकुर जी की जो उद्धरण है, उनकी पंक्तियां हैं, वो दोहराना चाहूँगी। स्वतंत्रता के उस स्वर्ग में मेरे देश को जगाओ जहाँ मन भयमुक्त हो और सिर ऊंचा हो, जहाँ ज्ञान मुफ्त हो, जहाँ दुनिया को संकीर्ण घरेलू दीवारों द्वारा टुकड़ों में नहीं तोड़ा गया हो, जहाँ सत्य की गहराई से शब्द निकलते हैं, जहाँ अथक प्रयास पूर्णता की ओर अपनी बाहें फैलाता है। ऐसे बेहतर भविष्य की आशा लेकर हम फिर एक बार कल जुटेंगे। और एक थोड़ी सी दुविधा है, यह मुझे संकोच हो रहा है बताने में कि हमारे आज के जो मुख्य अतिथि साहब राहुल कुमार पुरवार जी थे, जिनके आने की यहाँ संभावना थी। अभी खबर मिली है कि उन्हें अनायास ही सीएम ऑफिस बुलाया गया है, जिससे उन्होंने अपनी यात्रा बीच में ही रद्द कर वापस से वो सीएम ऑफिस की तरफ चले गए हैं। तो हम आज की जो ये कार्यशाला थी उसको यहीं संपन्न करते हैं। और मैं हमारे ट्रेनिंग एंड प्लेसमेंट ऑफिसर श्री मकसूद आलम सर से अनुरोध करती हूँ कि आप हमारे आज के मुख्य प्रवक्ता को कॉलेज का थोड़ा सा परिभ्रमण कराएंगे और जो भी लैब से संबंधित और स्टाफ हमारे हैं अपने थोड़ा सर का मदद करेंगे हमारे कॉलेज के परिभ्रमण में। और इसके साथ ही आज की कार्यशाला यहीं संपन्न होती है। कल सुबह फिर 10 बजे हम यहाँ मिलेंगे। धन्यवाद।